In this first part, we are going to look at how to set up the file systems in Revit and Rhino in order to have a good environment for moving data between the systems. On any project, you usually, or most often, according to my experience, start with some kind of map file or a file that is in the DWG format or a laser scanned point cloud, saying something about the location of the site. I have collected for you in the setup folder of the downloaded material for this course a DWG file that's simulating a site in a location in Beirut, Lebanon for the project Banque Libano-Française that Snøhetta completed or has been designing during the course of 2017 and 2018. And thanks a bunch for the bank, the client, and the Snøhetta employees who have agreed to use this site and building as the basis of this course. So the first thing that we're going to do is we're going to open this DWG, but we're going to do that inside Rhino 5. So let's start by opening Rhino 5 from our desktop, or we're going to start a new file. And the first thing that I want to highlight is the importance of having the same units in the different systems. So when you start Rhino, you want to select either feet, inches, centimeters, millimeters, large objects, or small objects. So for this project, we're going to be using large objects, meters. That's going to open an empty Rhino file. We can expand the top view by double-clicking on it and dragging it out a little bit. The DWG, that's called site DWG, is modeled in meter units. Units meters is set up in the file, and the actual geometry inside the file is modeled in meters. So we're going to drag this right into our Rhino file, and we can import that file by choosing Import File. OK. This is what the site looks like. Over to the top left corner is the ocean of the Mediterranean Ocean outside of Beirut, Lebanon. And this is the site near the area called Mar Michael in Beirut. This map file, like so many other map files, is oriented to true north, while our building has a project north direction. So there are two things basically we're going to do in this map file before continuing to working on the design itself. We're going to move the entire site closer to the local origin of our CAD system. We have chosen, before starting this course, a proposed origin that's going to act as our project origin, the local 000 of the project. This is maybe one of the most important things that you can do in order to have a good interaction, whether you're using Grasshopper, Dynamo, Excel, whatever, between Rhino and Revit, you want to make sure that they have the same origin, the same project origin. You also want to make sure that you are moving all this geometry closer to the origin than what normal site files or map DWG files have. So when I zoom out in this Rhino file, you will see that the local origin of your Rhino file is located at the bottom left corner somewhere. Now the distance between the map and the origin can vary greatly across the planet depending on which coordinate system the local authorities are using. So here we're going to move this guy closer. You can move it just selecting everything and then using the gumball and moving the site closer. It doesn't really matter. If you want to keep a reference or the difference between the local origin and the global origin, you may want to check the coordinate of your proposed project origin and write it down for your own use and put it in your BIM execution plan or whatever, and just keep that reference and don't do like I just did and start moving it. So let's move the entire thing. You can either zoom out like I did and just select everything, or you can Control A on the keyboard by selecting everything. One note when you're doing that inside Rhino, if you already know Rhino, this is no problem. If you're new to Rhino, you may want to make sure that all the layers are turned on. You see that the layer 1, 2, 3, 4, 5 here was already part of the template, so you can purge these layers by writing purge, enter, and enter. You're stuck now with only the layers that was originally in the DWG file. So you want to make sure that all these layers are turned on, and secondly, you want to write or type show in the command line of Rhino and just make sure that no objects are hidden in the viewport. So then again, go Control A. Sorry for zooming in and out so much. I want to zoom in and locate the proposed project origin, execute the move command, and then snap to these intersections or midpoints. You're now inside the move command, moving these geometries with your cursor, and just type 0 on the keyboard and enter. Now I'm going to type ZE and enter, and I'm assuming it extends to the new local area where the building is going to be designed in our CAD and BIM software. So you can see now that the 000, the local origin of the Rhino file, now corresponds with the proposed project origin inside Rhino, and this is a good thing. The next thing we want to do is a rotate command. We want to orient the system of our building so that it aligns with the main structural grid of the building. This is obviously something that's not always available to us, so sometimes, depending on the geometry of the site or the geometry and orientations of the buildings on a site, sometimes maybe it makes sense to model in true north, which is what we're seeing now in front of our screens. This is a true north site, so the y-axis inside Rhino aligns with the true north direction of the world, pointing towards the North Pole. On this building, the east and south facades are making together a 90-degree angle, and these are also defining a big part of the structural grid on this building. So for simplicity reasons, basically in order to have a simple setup of modeling inside CAD and BIM, we want to rotate the entire world actually in order to be modeling the south and east facades along the X and Y axis of the site. As I said, not always is this necessary or even a good thing to do, but on this site, this is certainly beneficial for the design process. So again, we're going to Control A by selecting all the geometry. By the way, one important aspect to remember when you're doing this is that this should really be done on all files that is going to go in and out of your CAD and BIM software. Right ROT to rotate the geometry. Now we don't need to snap to any origin. Snapping is always a little bit scary, so let's just type 0. And then we're going to break the rule that I just said snapping is scary. We're going to snap to this line, and then we're going to force it towards north by snapping to this line. Alright. So now the east facade and the south facade of our site is completely aligned with the Y and X axis. The reasons for doing this are obvious to me, maybe not to you, but any CAD and BIM software that works in coordinates, a line going from 0 and along the X axis is going to be mathematically much easier to describe than a line going like this line, for instance. So this line is easier to calculate than this line. Alright. I don't know if I can try and explain it in a simpler way. So this is the basic setup that we want to have. Now the next thing I want to do is I want to save this file because we started by importing a DWG file into Rhino. Now DWG files are not the native Rhino files, so you may want to save this file. Go Save As. We can save this in the same folder and just call it Setup. Now this Rhino file is going to be the basis of our CAD when we're starting to model. Now we have a site file, original DWG file that we moved inside the setup file. Let's move over to Revit to see how we set up the Revit system in the same way. I'm going to open Autodesk Revit 2018.2, which is the version used for this course. Proceeding by going to the Open Projects, finding the Setup folder, and opening the empty Revit file setup.rvt. As I said, this is an empty Revit file. Let's first check the units used in this system. I'm going to go to Manage tab inside Revit, find Project Units. By the way, with the shortcut UN, you can access these settings without searching through the menus inside Revit. Length units is what determines the main units of the file. So we want to open this guy and then just confirm it's set to meters. I'm usually also using, when I model Revit files in meters, I use rounding 3 decimal places with suppressing trailing zeros. If you want to use the unit symbols or not, you can choose. I'm going to disable that guy. I'm moving on to the site floor plan, where you see the 4 elevation symbols of a default metric Revit file and the origins comprised in this file of 2 reference planes and a project base point and a survey point. These guys we're just going to keep in the local original Revit origin, which so Revit has at least 3 origins. It has the local original origin that never moves. It's always going to be in the location of these reference planes unless someone moves the reference planes. By the way, mentioning that, maybe we should just go ahead and pin them. And then the project base point and the survey points. The survey point we're using to give that reference between the global and local origin, but also we can create multiple locations inside Revit and then use different coordinate systems for exporting to IFC and so on. We're not going to cover all those scenarios now. Just make sure that you keep at least the project base point in the local original Revit origin. ZX in Revit for zoom extents, we're going to start by importing some of the geometry from our Rhino file. We're not going to import the DWG file that we originally had because it's not moved and located to the local project origin. We're going to start off by selecting the line work on our map layer. So first hide the layer's origin, property line, building outline. Right-click on the map layer, select Objects, and then go File, Export Selected, name it Map, and then choose DWG, which is great for a simple way of moving points, lines, and text from Rhino to Revit. Let's hide the map layer. We're going to display the property line layer, the origin layer, and the building outline layer. Actually, let's go ahead and hide the origin layer. We don't really need that. So I'm going to select the property line and the building outline. I'm going to File, Export Selected, and repeat this. So do we want to name this? We can just name this Property, and then know that the building outline is located in the same CAD file. Moving this into Revit can be done in a multitude of multiple ways. A general note on this course is that it's not going to cover every possible scenario of how you can move data between different systems. We're going to cover the most important things and the ways that were used on this project. So when you're getting DWG files into Revit, the 2 main ways of doing that is to move to the Insert tab. You want to link it or you want to import it. The link tool in Revit will give you the opportunity to reload it in case you do some changes. So let's say maybe the property line changed. You want to go back into the Rhino file and change it. You can overwrite the DWG file and then just relink it into Revit. If you're going to the Import CAD tool, that's going to more or less do something like baking the DWG geometry inside Revit. You won't have the ability to update it later, but you can delete it, obviously, and then import it again. But it will follow a Revit file if you send it to, for instance, local consultants in Beirut. So pros and cons of the different approaches. We want to go to the link CAD and we want to find the map DWG file, and we want to have a little look on the different settings when you're importing alien geometry into Revit, in this case DWG files. The first thing we want to do is we want to have a look at the current view only option. Enabling this will basically turn this DWG file into an annotation, a view-based annotation element. It's not going to be visible in 3D views or sections or other plan views. It will only be visible in the site view unless you select it afterwards and copy it to other plan views. This is a good thing, I think, for the map DWG file, and probably a bad thing for 3D geometry like BREPs. So let's keep this guy on for now. Color settings, preserve. You can choose invert, preserve, or black and white. Let's move on. This is less important. Layers, levels. If in your DWG file you have hidden layers or layers that are turned off, you can choose visible, or you can even choose specify to enable different layers. I usually go with visible as a good working progress, unless you want to choose actively specify or just use all. But if you use all, there's a chance that layers that you hid in the DWG files are going to be displayed in Revit. Second to last, import units. As long as you set everything to meter in the two files, you're good to go with auto detect. If you have millimeters in the Rhino file and meters in the Revit file, you may want to make sure that this is set to meters. As I said in the beginning of the course, a good setup, you have the same coordinate system, the same orientation, and the same units in all these systems. And most importantly, maybe at the end, you want to make sure that you're using auto origin to origin. On my system, this is set to default. I don't know if that's the case on your system. If it's not, you definitely want to go and make it origin to origin. You'll probably get the same result using shared coordinates as long as the survey point is not moved in Revit. But let's keep it simple. Origin to origin. Stay away from any center to center or manual origin unless you absolutely need to in some other case, maybe. But in this case, when you're dealing with coordinate systems, keep it origin to origin. This is going to align the Rhino 0 with the original Revit 0. Okay, let's go open. Oh, and there we go. Beautiful map. We're going to repeat this with the property DWG, and you will notice now that all the settings that we just used are still applied. So now we can just go open. And we have building outline, the property lines, and we can start doing things in Revit. So one of the things that we can start off, maybe, we can just model 2 or 4 basic walls using the finish phase exterior along the building outline lines like this to be able to see this stuff in 3D because we used current view only importing the CAD file. We can also go to massing and site and add property lines by sketch, tab select all the property line DWGs. If you find it hard to find those lines, you can go VV. That's the double clicking on V on your keyboard, imported categories, and then turning off the map DWG and just use the property line subcategory of the property DWG file. Finish. And the final setup that we need to do in order to start designing this building, you will see now if you're moving to the 3D view or the perspective view that north and back is exactly the same. You'll see the same in the 3D view. The ortho 3D view front and south is the same. Now this is not the case, as you may remember. In the Rhino file of the map, we rotated the entire site so that we could model efficiently along the X and Y axis. So we want to make sure that that setting also gets transferred to the Revit system. Go back to the site view. Actually, this is a pretty good case where we want to look at the updating of CAD files because I didn't export the origin line work from the Rhino file. I don't have a reference to the original north, the true north, if you may. So let's go back to the Rhino file. I'm going to turn off the map layer, select all the line work, the property line, the building outline, and the origin. Export selected, overwrite the property DWG. Going back into Revit, we go to Insert, Manage Links, CAD Formats, Property DWG, and click Reload. Click OK, and voila! You can now see the direction, which is the true north. Okay, before we proceed, let's just save this file. I want to ZX, zoom extends in Revit, save as project. We're going to call this setup modified, just for keeping it. And we're going to go to Manage. Under the subcategory of Tools, Project Location, we're going to open Rotate True North. Oops, we need to orient the view to True North. Properties, Orientation True North. Going back to the Manage tab, Project Location, Rotate True North, and we'll zoom in on the origin and rotate from Project North to True North. Whoops, I always do this in the wrong sequence. Please undo and then do the same operation, just rotating from True North back to Project North. When you're doing this, it is really important that you snap to geometry, because as you could see, if you allow me to repeat this command, I'm going to rotate True North from Project North from True North to Project North, you will see 13.92 degrees. Now this is just a display unit for you to see. This is not the real angle between True North and Project North. The real angle has multiple numbers behind the dot, so it's probably 13.92 something. And in order for your design system not to get wrong data, if you do this, for instance, using just 13.92 and not snapping, this corner up here on the northeastern side of the building may be deviating from what the site actually looks like. So just snap this like this. Okay. Oh, this is perfect. Now we're back into True North, and we can choose the orientation of our plan drawing to be Project North. And if we go back to the 3D view, you will see that if I click front, I get the actual, the 3D view aligns with the x-axis, but if I click south, I'm looking towards the south, the true south facade of the building. And this is basically the most important setups that we need to do. In the next chapters, we're going to start looking at how we can move different types of geometries between Revit and Rhino, both moving from Revit to Rhino and getting geometry from Rhino into Revit.